Hi everyone. In this video, I'll show you how to rationalize denominators. And at the very end of the video, there's a little bit about the history of why we even do this. But first of all, you're probably here because you want to know how to do this for your homework or a math test. So here's how we rationalize. If we have this expression, 2 over the square root of 5, to rationalize it, we multiply by the square root of 5 over the square root of 5. And recall that when we multiply by something over itself, that is equivalent to 1. So it's legal to do that. So we multiply across and we get 2 square root of 5 over the square root of, well, 5 times 5, that's 25. And then we simplify. Our numerator stays the same, and the square root of 25 is, of course, 5. So we've taken care of that one. We got rid of the radical in the denominator, and now we have our rationalized form. Now let's say we have a problem like this, 3 over 5 minus the square root of 2. Now our first impulse might be to multiply by that denominator over itself, because we did that in the first example, and that worked out great. But this is a little different because we've got something being added or subtracted here. And if we were to multiply just by that thing, we will end up with still having a radical in the denominator. So what do we do to get rid of that? We multiply by this thing called the conjugate, which sounds very fancy or complicated, but it's not. All it is this expression, and you change this sign. So if you have subtraction, you change it to addition like we did here. If you were to have addition, you would change it to subtraction. And here's why that works. When we multiply these things, now nothing exciting is going to happen in the numerator. We're just going to multiply 3 times each thing here, and that gives us 15 plus 3 radical 2. Down here, remember, always when you're multiplying binomials like these guys, to FOIL, right? So first terms, 5 times 5 gives us 25. 5 times radical 2 gives us 5 radical 2. 5 times negative radical 2 gives us negative 5 radical 2. And then these last terms are radical 2 times radical 2, and then there's a negative sign, so that's minus radical 4. So here's the magic of this method, is that these terms cancel out. Of course, this is going to simplify, so we get 15 plus 3 radical 2 over 25 minus, and that's 2, of course. So we get our final answer of 15 plus 3 radical 2 over 23. The technique of multiplying by the conjugate also applies if you have I in the denominator. Remember, that is a radical because I equals the square root of negative 1. So multiplying by the conjugate in this case, so notice we have 2 plus 7i here. So what will we need to put over here? We have to put 2 minus 7i. And when we multiply those out, using FOIL again, we get, let's see, 10 minus 35i minus 6i plus 21i squared. And that's all over, let's see, 2 times 2, that's 4, minus 14i, plus 14i, minus 49i squared. And we can simplify. Now remember, I being the square root of negative 1, that also means I squared equals negative 1. So here we have this I squared and this I squared. You can think of it as, like in this case, 21 times negative 1. And in this case, negative 49 times negative 1. And that'll be important as we continue to simplify. So in our numerator here we have 10. That'll give me minus 41i. And then this 21 times I squared, which is 21 times negative 1, gives me negative 21. In the denominator, well, these terms cancel out, which is great. And then we have 4 minus All right, so negative 49 times I squared, negative 49 times negative 1 gives us positive 49. And so in our final answer, we combine these guys, 10 and negative 21 give us negative 11, and then minus 41i over 4 plus 49, which is 53. And in a lot of cases, you will be asked to write your final answer in standard form, a plus bi. That just means the real number and then the imaginary number, being there's your complex number standard form. So you could also write this as negative 11 over 53 minus 41i over 53. So those are the techniques for rationalizing, but you might be asking yourself, well, why do we do that anyway? I mean, what is the point of that? I can do this operation on my calculator. Well, back in the olden times, before calculators, think about actually dividing this expression with pencil and paper without the benefit of rationalizing. So think about this. Okay, the square root of 2 is approximately 1.414213,562, etc. And like a lot of people who are into math, I'm not always that crazy about doing a long division problem by hand. Let's see how this one would set up. Let's see, I'm dividing into 3, something into 3, but it's going to be 1.414213,5. I'm running out of room, into divided into 3 point, and it's like, oh, okay, I mean, I could do that, but I don't want to do that because I'm lazy. So rationalizing was really a shortcut in a way, because think about this. If we rationalize this expression, just using that first technique, we get 3 radical 2 over the square root of 4, which is, of course, 3 radical 2 over 2. And now it's much easier to, for example, divide 2 into 3 and then multiply it by this number over here, because then you have a much more convenient operation to do mathematically. So just a little quick history about why we actually bother to do rationalizing. So if you've watched this far into the video, congratulations, and now you know a little bit more about some of the history of this stuff. As always, thank you for watching.